Hi guys, and welcome to your last lecture on pre-calc polar graphs. I know, super exciting. All right, so our last two that we have on our graphs are, let me get my pen on, lemniscates and spiral of Archimedes. So first one that we are going to do is the spiral. So when you have an equation, r is equal to a times theta, the graph is going to be a spiral. So if theta is greater than 0, the spiral is going counterclockwise, and if theta is less than 0, the spiral is going clockwise. So we have a couple of examples here. So we have r is equal to theta, r is equal to 2 theta, r is equal to negative 2 theta, and r is equal to 1/2 theta. So these spirals, unlike our other graphs, which trace over each other as we go around the circle more and more, these continue to go on forever and ever. But we will typically just go from 0 to 2 pi. I'm not that mean. I won't make you guys do that forever and ever. I'll just have you go from 0 to 2 pi. So if you watched the lecture on lemniscates before this, which I'm hoping you did, this is going to be a very similar process for graphing. The first thing that we're going to do is we are going to make a table. So we know r is equal to 3/2 times theta. And then we have our theta. So again, just like we did with lemniscates, we're going to take our easy theta values. So our axis points, 3 pi over 2 and 2 pi. All right, so when theta is equal to 0, we just plug that into the equation. So we will have 3/2 times 0, which we know is 0. Next up, we're going to plug in pi over 2 in for theta. So 3/2 times pi over 2. And this, I don't expect you to know this off the top of your head. Just plug it into your calculator. I already did the calculator work for these. So I'm just going to be putting numbers down, but know that I did have to put it into my calculator. That's 2.4. Then put in pi. So r is equal to 3/2 times pi, which is equal to 4.7. Next, put in 3 pi over 2, 3/2 times 3 pi over 2 gives 7.1. And then last but not least, plugging in 2 pi, 3 over 2 times 2 pi gives 9.4. So we start out just plotting these points as we have done before. So 0, 0. When theta is equal to pi over 2, when we are on our positive y-axis, the distance from our positive y-axis is 2.4. So I'm going to say that these go up by 2's. So this out here is 10, okay, because there's 5 lines. So 2.4 is going to be, I don't know, like somewhere right here, okay? Next up, when we have pi, we're at 4.7. So just about here. 3 pi over 2, our negative y-axis, we're at 7.1. 2, 4, 6, 7.1. And then finally at 2 pi, we're at 9.4. And then remember, these just have a spiral shape. So, oh my goodness, hello. What is this? All right, so that is your very ugly spiral. So we have r is equal to 3 pi over 2. So as you know, I love Desmos. R is equal to 3 over, oh, I should probably, click in the box. R is equal to 3 over 2. It's pi. What? Oh, 3 over 2 times theta. Wow, okay, sorry guys. It is Sunday night and I am losing a little bit. So if we keep zooming out, this keeps going on forever. It should keep going on forever. I don't know why they stopped right there. But there you are. There is your spiral. So the one big thing to remember with the spiral is that you're not taking the sine or cosine of these graphs. You are literally taking the number pi over 2, so 3.14, and you're dividing it by 2 and multiplying it by 3 over 2. So that is the weirdest thing about spirals. Next up, our last graph is our lemniscate, or the bow tie. I remember when I learned this, they called it the infinity sign. You'll also hear propeller. So the general form of this is you have r squared is equal to a squared times cosine of 2 theta, or r squared is equal to a squared sine of 2 theta, okay? So if you are at cosine of 2 theta, your petals are going to be at 0 and 180, here. And then if it's negative, they will be at 90 and 270. And then if you have a sine, you're going to be at 45 and 225. And if it's negative, you're just going to flip-flop. So these ones are a little bit different. We kind of do a table, but you'll see. So first thing we want to do, we don't really want to deal with r squared, okay? Let's just get rid of it. So if we get rid of that, we have r is equal to the square root of 25 times cosine of 2 theta. And remember, when we take the square root, we have to deal with plus and minus. So that's what r is equal to. And we know that since we have a cosine right here, our petals will be, and it's a positive cosine, will be at 0 and 180 degrees, or 0 and pi, whichever way you like thinking about it better. So we have our theta here. So when theta is equal to 0, because we know that's going to be one of our petals, when theta is equal to 0, r is equal to plus or minus the square root of 25 times the cosine of 2 times 0, which is just 1. So then this is equal to plus or minus the square root of 25, which is plus or minus 5. So technically what we have right now are the points 0, 5, and 0, negative 5. So 0, 5 is going to go right here, but then remember, in polar coordinates, if your r is less than 0, like negative 5, you go backwards on your theta line. So your theta line for 0 is right here, but instead of going to the right, you're going to be going to the left. So your other petal occurs at, I totally flip-flop these. I am so sorry. It should be r theta, not theta r. My goodness. 5, 0, negative 5, 0. Wow, okay. 5, 180. So this is going to, and then you have this point here because we know that this is what the graph is going to look like. So draw this something like this. And there's your lemniscate. All right, so let's see how much time we have left. All right, so with the time that we have left, I'm just going to whip through these 2 examples here. I want you guys to pause the video, give these a try before I start. Welcome back. This one right here is a spiral of Archimedes, so we're going to start with our chart. So we have r is equal to 4 theta, and then our theta values that we're going to use, as always, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Plugging those in, r is equal to 4 times 0 equal to 0. Pi over 2, 4 times pi over 2. Again, I punched these into my calculator beforehand. This is 6.3. 4 pi is about equal to 12.6. 4 times 3 pi over 2 is equal to 18.8. This is getting a little bit cramped. And then 2 pi, 4 times 2 pi is equal to 25.1. So we're going to say that each one of these lines is 5, so they go out to 25 right here. Okay? So we start off at 0, 0, Next, when we are on our positive y-axis, we have 6.3. When we are on our negative x-axis at pi, we are at 12.6. When we are on our negative y-axis, we are at 18.8. And then our last point is 25.1. So we just connect those dots. And as always, I am not grading you guys on your artistic ability because clearly I have none. And last but not least, we have one more lemniscate for us. So first thing we're going to do, we don't want to deal with r squared. So we say r is equal to plus or minus the square root of 9 times sine of 2 theta. And remember, since we have a positive sign, our petals are at 45 degrees and 225 degrees. So they're going to be on this line and this line here. All right. So what we want to do now is we want to take our theta value of 45 degrees. So plugging that in, we have r is equal to plus or minus the square root of 9 times sine of 2 times 45. 2 times 45 is 90. The sine of 90 is 1. So we are left with r is equal to plus or minus the square root of 9, which is equal to plus or minus 3. So we know then that our petals are going to be at 345 and negative 345. This should be degrees. And then remember that this one here is actually the same as 225. So graphing those in, we can count each of these lines as 1. This line here going out 1, 2, 3. And then however you want to draw in those little petals or propellers or bow tie, whatever you want to call it. There you are. So I hope you guys enjoyed your last polar graphs. Be sure to ask questions in either the attendance or the discussion board if you have them. Happy Monday!